Good morning, students. I hope that by this time you have completed the second lesson, acid bases and salts. As I told you before, there will be a class test today. I will upload the questions in the Google Classroom by around 3:30. I want everyone to write the class test. Okay. Now let me continue my lesson, metals and non-metals. In the last class, I have explained what is an ionic compound or an electrovalent compound. We have seen that ionic compounds are formed by the transfer of electrons from a metal to a non-metal. Transfer of electron. Now, another point we have to discuss here is name the ions present in these compounds. Name the ions. In order to understand this concept, we have to go back to the 9th standard question. What are ions? Ions are charged particles. Positively charged ions are called cations and negatively charged ions are called anions. Also, should be thorough with the valencies of monovalent, divalent and trivalent anions and cations. Okay. Now let's go through this example. Name the ions present in magnesium chloride, calcium chloride and potassium chloride. Let's have a look at this example. Magnesium chloride. Magnesium chloride is a compound containing elements magnesium and chlorine. Now the ions present in it. We know magnesium is having valency 2 plus. So Mg2 plus 2Cl minus. Why 2Cl minus came? Because in the case of the compound magnesium chloride, 2 chlorine atoms are present. So we have written 2Cl minus. Similarly, calcium chloride. Calcium is having valency 2 plus and the chlorine 1 minus. So Ca2 plus 2Cl minus. Next, potassium chloride. K plus Cl minus. K plus, that is the cation. Cl minus is the anion part. Sodium chloride. Na plus Cl minus. Similarly, calcium oxide. Calcium 2 plus and oxide ion 2 minus O2 minus. So Ca2 plus O2 minus. Next, lithium chloride, LiCl. Li plus is the cation and Cl minus is the anion. Still, if you have doubts, students, please go through that. The valencies of monovalent, divalent and trivalent anions and cations. Please go through that, write and study. Then you will be having a clear picture. Next, let's study the properties of ionic compounds. First one, physical nature. Ionic compounds are usually solids. They are hard due to the strong electrostatic force of attraction between the ions. For example, consider the compound potassium chloride. Potassium chloride is an ionic compound or an electrovalent compound. It is a solid and it is hard also. Why? Because there is a strong force of attraction exists between the positively charged cation, I mean the potassium ion, and chloride ion, Cl with a minus charge. One is plus charge and another is minus charge. So strong electrostatic force of attraction exists between the two ions. Hence, they are hard. Now, second property, ionic compounds have high melting point and high boiling point. These are one mark questions can be asked. Why? Ionic compounds have high melting point and high boiling point. In the case, then you have to write as in the case of an ionic compound, there's a strong electrostatic force of attraction between the ions. Then, considerable amount of energy is required to break the strong inter-ionic attraction. Hence, Ionic compounds have high melting point and boiling point. Third, solubility. Ionic compounds are soluble in water but are insoluble in solvents such as kerosene oil, petrol, etc. Next, fourth one, conduction of electricity. Ionic compounds will not conduct electricity in the solid state. Why? What is electricity? Electricity means the movement of electrons. In the case of an ionic compound, there exists a strong electrostatic force of attraction between the ions. So, there are no ions present. Ions are tightly held together by strong force of attraction. So, the movement of ions is not at all possible here. But if if it is in a molten state or if it is dissolved in water, if the ionic compound is in the molten state or if the ionic compound is dissolved in water, what happens? The electrostatic force of attraction between the oppositely charged ions have overcome due to heat and it will conduct electricity. So when an ionic compound, when it is dissolved in water or when it is in the molten state, the force of attraction between the oppositely charged ions will not be there. And the ions will be present there and the ions are free to move. Hence, they can conduct electricity. So these questions are very, very important for your board examination. Why ionic compounds are hard? Why ionic compounds have high melting point and high boiling point? Ionic compound will not conduct electricity in the solid state. Why ionic compounds will conduct electricity in the molten state or when it is dissolved in water. So study this areas well. Now let's go through some index questions. Draw the electron dot structure of sodium, oxygen, magnesium, etc. Electron dot structure. Now sodium we know atomic number is 11. So the electronic configuration is 281. 2 electrons in the K shell, 8 in the L shell and 1 electron in the M shell. When you are showing the electron dot structure, only the electrons present in the outermost shell. I mean the valence electron will be shown here. So only 1 electron is present in the M shell. That only we are showing here. No need of writing everything. The writing like this, it is understood. Write a K, L, M. Okay. Then in the case of oxygen, atomic number is 8. So the electronic configuration is 2, 6. So K shell 2 electrons, L shell 6 electrons. That 6 electrons only you can show here. 2, 2, 4, 5, 6. Next to magnesium. Magnesium atomic number is 12. So the electronic configuration is 282. Here we have to show only 2 electrons, which is the valence electrons. Now the next question mentioned in the textbook is show the formation of sodium oxide, Na2O, and magnesium oxide. So in order to explain this concept, Na2O, sodium oxide, sodium, 1 electron in the outermost shell. So Na2, so 2 sodium atoms we have to show. And oxygen, 6 electrons are present here. 2 plus 2, 4, 5, 6. 1 electron will be fully transferred. Another electron also fully transferred. So in general, sodium will lose how many electrons? 2 electrons. Okay. 1 electron sodium is losing here and another electron in sodium is losing here. So sodium oxide, electronic configuration of sodium is 281. So sodium loses 1 electron. So 28 is the electronic configuration of sodium ion. Like that, 2 sodium ions are present. 28, 28. Then oxygen is getting how many electrons? 1, 1. two electrons, oxygen is taken. So O2 minus. This way you have to write. Similarly, magnesium oxide. Magnesium 282. So magnesium is transferring two electrons to oxygen. So since magnesium loses two electrons, Mg will become Mg2 plus. Its configuration is 2,8. Similarly, oxygen is getting two electrons from magnesium. So O2 minus, or 8 electrons will be here, or O2 minus, Mg2 plus O2 minus, or MgO. Now we have to study occurrence of metals. We are going to enter the metallurgy part. Before going to the metallurgy part, I want everyone to be thorough with the valency part. If you are getting a compound, we should identify which are the ions present in it. Then that metallurgy part will be very easy for you. Okay, so study well and clear of your doubts. Thank you.